In this video, we are going to show how to maintain and troubleshoot a network using the cable and fiber test features of the PingerPro from Psiber Data Systems. A large number of network problems are related to the physical layer. Wire map and length are excellent tests for identifying and locating cable faults. The length test uses TDR technology, which stands for Time Domain Reflectometry. A TDR measures distance to a cable discontinuity by sending out an electrical pulse and measuring the time it takes to see the pulse reflection. Distance to the discontinuity is calculated by multiplying the speed of the pulse by the measured time and dividing by 2 because the pulse traveled out and back. Fiber does not require multiple conductors like copper and does not emit EMI, eliminating crosstalk. This reduces fiber testing requirements to mainly an attenuation loss test. New installations should always be tested for correct wire map to ensure the link will work when devices are connected. Additionally, patch cables can be subjected to hard use and develop problems that can be identified with a wire map test. Pressing the cable test button on the home screen brings up the cable test menu. The wire map shows how the wires connect from one end of a cable to the other. There are 4 wire pairs in an Ethernet cable: 1, 2, 3, 6, 4, 5, and 7, 8. Each wire in the cable must be connected to the correct pin at the far end plug or jack with good contact in the termination. Select the wire map test and plug one end of the cable into the PingerPro and the other end into the wire map terminator that comes supplied with the PingerPro. The wire map test will not work unless the wire map terminator is attached to the far end of the cable under test. The PingerPro terminator is designed with a female jack for testing cables with an RJ45 connector and a male RJ45 plug for testing cables connected to a wall outlet. Pressing the play button will begin the test. This is the wire map of a good cable. When terminating an end of a network cable, it is easy to miswire a plug or jack, which can cause a device not to work when installed or reduce device performance due to loss or corruption of packets. Here are some examples of incorrect wire maps that the PingerPro can detect. An open pair occurs when a wire is not physically connected or the cable has been damaged with one or more wires cut. A short pair occurs when a wire is physically connected to another wire within the cable or at a connector. A cross pair occurs when one twisted pair, like 1, 2, is connected to a different twisted pair, like 3, 6. The usual cause of a cross pair is a 568A termination on one end and a 568B on the other. A reverse pair occurs when wires within a twisted pair are switched on one side of the cable. A split pair is the most difficult wire map problem to detect. It occurs when a pair is connected using wires of 2 different twisted pairs. One wire in each pair is reversed on both ends, which causes the signal to be sent on pairs that are not twisted together. Because the wires are not twisted, they do not cancel the EMI generated by the wires and have very high crosstalk. A device installed with a cable that has a split pair will usually connect and operate, but performance will be poor due to lost and corrupted packets caused by the high levels of crosstalk. Verifying that a cable has been connected properly is a basic network task that can be accomplished easily with the wire map feature of the PingerPro. When you have completed a wire map test, press the Save button to store the data. The data can be recalled later for review or exported to the PingerPro tools to document the test results. A length test is used to electrically measure the length of a cable or identify an open or short fault and give the distance to the fault. This test is run from just one end of the cable and can be run from either end. The PingerPro will measure cable lengths up to 650 feet or about 200 meters. From the wire map screen, press the length button to go to the length test screen. Attach an Ethernet cable to the PingerPro. Make sure that the far end of the cable under test is not connected to the terminator or any device. Press the play button to run the test. By selecting the settings button, you are given the option to select either meters or feet for the length measurement. The NVP, or nominal velocity of propagation value, used in the TDR measurement can also be adjusted and should be set to match the cable type being used. The NVP value can be found in the manufacturer's specifications for the cable. The PingerPro uses a default NVP value that is typical for a wide range of Ethernet cables. Using the correct NVP value for the type of cable being tested will provide the most accurate results. These test results can also be saved by pressing the Save button. Once exported to the PingerPro tools, reports can be generated and printed. Pressing the tone button will bring up the tone generator. The tone generator sends a signal down a cable that can be detected using a Psiber cable tracker probe that is available as an option. Connect a cable end to the PingerPro. Select one of the tones and hold the cable tracker probe to the connected outlet or a cable and you will hear the tone. This function is used to trace the path of a cable to locate a fault or identify a specific cable, outlet, or punchdown that would otherwise be difficult to identify. The port identification feature, called Port ID, is used to blink the link LED on a switch at a fixed blink rate. This allows the user to identify which cable or outlet is connected to a specific port on a switch. In the tone page, press the Port ID button to navigate to the Port ID screen. Connect one end of a cable to the PingerPro and select one of the speeds. Notice the link LED on the switch blinks on and off in sync with the PingerPro. Different blink rates are provided to work with various switch models and manufacturers. Note that some switches require an extremely slow blink rate and are not supported by this feature. Verify the blink pattern directly at the switch before conducting a test.